is it in the switch that turns on and off our light bulbs, powers our cell phones and computers? Stay with me for the next few minutes to understand how all this works. In my previous videos, we have learned about static electricity, one more form of electricity that we use in our day-to-day lives. Yep, you guessed that right. Today, we're going to explore current electricity. My name is Juhi, you're watching the TJ Show, and let's get started! What a beautiful view it is. Do you like waterfalls? Here we are at the Niagara Falls. Can you see water is flowing from one place to another place in only one direction? Here, we can see a water current. Water is flowing from a higher level to a lower level. Similarly, the flow of air in one direction is known as an air current. Also, we observe that heat flows from a higher temperature to a lower temperature. Do you see the ice melting in my hand? Yes, that is because the heat in my body is flowing to the cold ice cube, which is making it melt. Now let's dig down at a micro level. Electrons do flow through a higher potential to a lower potential through a conductor. This flow of electrons opens a whole new world called current electricity. We need some medium to make the flow of electrons. This medium is called as a conductor. All the metals are good conductors. That means that electrons can flow easily through them. For example, copper. Looking at the atomic structure of a copper atom, the last electrons in copper's outermost shell are easy to pull out. And this electron participates in the flow of electrons. Now this makes copper a good conductor. As we know, water flows from a higher level to a lower level. Air flows from a higher pressure to a lower pressure. Heat flows from a higher temperature to a lower temperature. Same way, electrons flow from a higher potential to a lower potential. What is a potential? Higher potential, lower potential, differences in potential? There are two types of charges on if matter gains electrons or loses electrons, positive charge and negative charge. Like charges repel and unlike charges attract. When these charged particles are separated, enough potential difference is created. This difference in potential creates a force which motivates the electrons to move. This is called an electromotive force. The unit to measure electromotive force is a volt and is denoted by a V. You might have heard or read in a battery that it has a certain number of volts. This battery has 1.2 volts. This is the measurement of the electrical potential of the battery. All these volts are sitting here waiting for you to use them. In order for electricity to move, it needs to be moved from here. Electricity wants to flow from higher voltage to lower voltage. If we create a conductive path between higher voltage and lower voltage, electricity will move. If you put something on its way, example a light bulb, then the electricity is going to do some work and light the bulb. So where do we find a higher voltage and a lower voltage? Every source of electricity, example this battery, has a positive side and a negative side. Positive side will have a higher voltage than a negative side. If we connect the positive side of the battery to the negative side, then the current will flow. Of course, to use this electricity, we need to insert something on its way so that it does some work for us. In this case, we're using a light bulb. This circular path, which is always required for electricity to flow, is called a circuit. So let's create a circuit. For creating a circuit, I have 2 batteries in series and a few wires and a light bulb and holder to use it and a switch. That's what I got. First, I'm going to connect the positive sides with each other. Like this. And the positive and negative the negative and positive sides with 1 wire. Over here, like that. And I'm connecting the negative with the negative. Oops, wrong way. There. Now I'm gonna add the light bulb. But before adding the light bulb, I'm going to switch it off. That is, I'm going to have an open circuit. Now that the light bulb is connected, ta-da! I lit the bulb. Now, open circuit and closed circuit. Do you observe that when I open the circuit, that is, I switch off the bulb, then the bulb goes off because the circuit is open. The electricity is not flowing because everything isn't connected. And when I connect this or I switch it on, then the bulb lights up because the circuit is closed. Thanks for watching. Bye guys.